Hello everyone, my name is David Guckian, and together with Sheng, we will share a solution for enabling Slimbootloader with LinuxBoot on an Intel MicroServer platform. In this talk, we will touch on the following: OCP OSF requirements, LinuxBoot, Slimbootloader, and the architecture and boot stages of this solution. In this slide, we're just outlining the Open Compute Project's open system firmware requirements and the link to these requirements. So Intel's open system firmware vision, going left to right. We have a mix of ingredients that include open source, closed source, and binary components, all put together to produce a fully featured EDK2 UEFI reference platform BIOS. This is a fully featured solution that is both very flexible in terms of platform enabling and very complex, which in part enables the solution to be so flexible. The more open source reference platform solutions also tend to be less complex and in turn have a reduced feature set and a less flexible boot solution. Normally, this is a very tailored firmware solution for a given platform design. Further over to the right, we see a variety of solutions that can be used in a wide array of products. From the traditional closed source solutions provided to customers on Intel reference platforms and via firmware vendors, to the open source solutions available through Min Platform, Slimbootloader, Coreboot, U-Boot, etc. And these solutions are typically leveraging binary components such as FSP. So basically, you can build a completely custom solution with something like Slimbootloader. You can build an EDK2 solution with minimum features, as is Min Platform. Or there is the full reference solution, firmware vendor solution, and have that reduced down to your needs. As for our server chip firmware solutions, at this time, our big iron Xeon server products are best served by EDK2 UEFI reference BIOS. Reasons for this is due in part to the features enabled on those products, which are complex, and UEFI is a proven solution having enabled multi-generations of server silicon. For Intel and some of Intel's customers, the validation framework for these chips is based on the UEFI firmware. UEFI has reliable, mature, multi-socket enabling support and capability, an extensive suite of security features, if perhaps a bit complex, authenticated boot, root of trust through ACM, TXT, boot guard. It's an extensive list. RAS features, reliability, availability, serviceability, essential for stable server performance and reliability and serviceability of the platform. UEFI provides a robust, reliable solution with fail-safe solutions, component firmware update solutions, etc. As for the microserver chips, the compute performance and power profile of the microserver chips, mostly SoCs, have opened up an even broader market range than may have been initially conceived. The original market segment may be content with UEFI solutions. It satisfies their use case, their needs. But other low power, low cost market opportunities have differing specific firmware requirements. Such requirements do not require a fully featured UEFI platform BIOS. Some have specific faster boot time requirements. Some need a firmware solution that enables them to remove or not include features that their products will not need enabled on their platforms. Some customers will have their own security solutions or just do not want the solutions provided by UEFI. And of course, some customers have their own bootloader solution and validation framework.
Thanks, David. I'm Ninshan. Just as mentioned by my colleague David, that MicroServer does require more specific use cases and also more simplified firmware solutions. So here we are recommending Slimbootloader as a best solution in this scenario. Why? The first thing, of course, is because it is open source and it has community support. Second thing, it provides all the basic features that you need, such as fast boot, security, such as secure boot and also Intel boot card, firmware updates, and last but not least, we provide permissive licensing. We understand that certain companies, they might want to add their own vendor codes before sending their codes to customers. While we encourage you all to upstream your source code to our GitHub open source, we understand that there might be specific business need in this scenario. So that's why we provide you the options to do so. So in all this combined together, it provides you a great experience in terms of development and also in terms of business requirements as well. And of course, it reduces the time to market effort because all the important features you need is already there. You just need to use it. And it also is very easy to do the integration work because everything you need to know is in our website. So for example, for a small company who want to set up your own firmware team, you just need to go to our website and get started, and every important step is there. So it's very easy to get started on Slimbootloader. That's what we provide to you. So now you know the benefits of using Slimbootloader. How about LinuxBoot then? Why use it? I'm sure most of you here are already well aware of what LinuxBoot actually is. It has been here for many years. The design principle of LinuxBoot is very straightforward. Basically, it means do less in firmware, do more in OS, which basically use the firmware to load the Linux kernel as soon as possible and use the Linux kernel to load the target OS or launch the user space that you need. So what can we get from here? Actually, as we all know, the OS layer itself has much more rich environment and much more capabilities and features. For example, Linux kernel can provide much more debug capabilities in a server side. And it also, as we all know, that there's much more developers in Linux compared to the firmware space. So by doing this, we are actually making the Linux drivers developers to become the firmware drivers developers as well. So in a way, it makes our firmware to be more resilient, and it makes the whole system to be faster because it reduces redundancy and then move those features, those implementation that can be done in the kernel from the firmware space to the kernel space. So how can we support LinuxBoot? Well, Linux provides a very powerful capabilities. Linux kernel is still lack of the knowledge of the platform, such as the memory controller and also UPI interface. So the solution is very simple. We still let the firmware to do the very minimum platform specific initialization and then transfer the control to the kernel space as soon as possible. And in the market, there's already mature solutions for UEFI, core boot, and also U-boot payload. So here today we are introducing the new support model, which is using Slimbootloader together with LinuxBoot. The concept is also straightforward. Let the Slimbootloader to do the platform-specific initialization with integrating the FSP binaries and doing the FSP-specific functions. And after that, we just pass the control to the LinuxBoot. So this flow represents a standard boot flow for Slimbootloader. So you can see from stage 1A under the kernel entry point. While you may not be able to see the text inside the boxes, so basically the blue box represents the call code for this standard flow. The orange boxes represents the portion that we call into FSP interfaces and talk to the FSP to do the silicon initialization portion. And the green box represents the platform hookbone, where we do the platform specific initialization. And you can see that some of the boxes in the stage 2 and the payload has been crossed out. Those boxes being crossed out is that can be replaceable by the Linux kernel. Other features that can be done by Linux kernel. So for example, the most notorious one is the PCI enumeration, because PCI enumeration actually takes a lot of time and resources. And a lot of cases, not only bootloader does it, but the payload also does it for a second time. So why not we just let the Linux kernel to do the PCI enumeration? So in that case, we reduce the redundancy from the firmware space and let the Linux kernel to do more complex and more comprehensive PCI enumeration to get all the drivers ready. So now we want to share with you our current status and so result has been done so far. We already upstream the LinuxBoot support as a standard payload for our Slimbootloader. So everything you need to know, just go to our website, Slimbootloader website, to follow the steps and try it out. As you can see, the enabling is very straightforward. So we welcome you to try out on yourself to experience what the difference can be made when you are using the LinuxBoot support. While we also prototype these on several platforms, what we want to highlight here today is we also prototype on the MicroServer chip, which is then written. And here is a reference performance data when we try it on that written. You can see that it just takes 1.8 seconds for the first boot from the reset until the kernel entry point, while 1.2 seconds itself is already taken by the memory training for the RAM. That's what we are going to offer you today. So just go to this website, Slimbootloader website as mentioned here, to go and try out yourself and then experience yourself on the Slimbootloader. We really appreciate if you can give us your honest feedback and also comment, and we welcome your discussion to help us and the community to make Slimbootloader and also to make open source firmware together as well, to be a more mature platform and let all the integration works better. So thanks everyone for this session. Thanks for having us. Have a great day ahead.
Right, feel free to ask any question. So we have one question so far by Kazusa. Asked that will NVMe driver be included in the LinuxBoot module? So here's a good thing is that with the LinuxBoot that whatever drivers which is supported by Linux currently can be directly deployed in the LinuxBoot. So we are basically using the Linux kernel as a boot module. So in a way, we are making the driver developer to be the firmware developer. So this is what we get, the benefit. So it's a good question. Okay. Yeah, there's another question by Daniel. Mentioned that can we feature the experiments with LinuxBoot on the website? Yes, of course. Until today, we have actually, as I mentioned in the slide just now, we have POC, the LinuxBoot on several platforms for Whiskey Lake, and also in this, we are using Deberton. So feel free to go to Slimbootloader website and try out yourself. We have the excellent guides over there. You can just go to the website and try it out. Yeah, I can sell the website. Okay. Okay, as another question, asking what is the difference between Slimboot and CoreBoot. In a way, from the boot flow standpoint, they are basically similar. Both are waterfall booting. The main difference is that Slimbootloader is actually using EDK2 based library. So in a way, especially those UEFI developers who are familiar with the UEFI space, they can get started with the Slimbootloader very fast because it's a very familiar workspace, and especially Slimbootloader is very simple, and you can actually there's a lot of guides provided online as well, so it's very good for the new developers to kickstart. And it's even better for new BIOS developers to start on Slimbootloader because it is also, as I mentioned, it's an EDK2 based code, so it's a good learning platform. Thanks everyone. Have a great session.